Let's solve this interesting problem about two objects thrown upward at different times. A rock is thrown vertically upward with a speed of 12.0 meters per second. Exactly 1 second later, a ball is thrown up vertically along the same path with a speed of 18.0 meters per second. Let's visualize their motion. The rock goes up first, and then 1 second later, the ball follows. We need to find when and where they'll collide. Let's write the position equations for both objects. For the rock, its position is equal to its initial velocity times time, minus 1/2 gt squared, where g is 9.8 meters per second squared. For the ball, we need to account for its 1 second delay, so we use t minus 1 in place of t. For them to collide, their positions must be equal. Let's expand the ball's equation. Then we can solve for t. At 1.90 seconds, they will collide. Let's substitute this time back into either equation to find the height. Plugging into the rock's equation, we get 5.11 meters. Now for part C, what if we reverse the order? If the ball is thrown first at 18 meters per second, and then the rock 1 second later at 12 meters per second, their paths will look like this. Using the same method as before, we can find they will collide at a different time and height. In this case, they collide at approximately 1.45 seconds and at a height of approximately 3.84 meters. Notice that changing the order affects both the time and height of collision.